Hey, what's up? Welcome back to another video. In this lecture, we will discuss about van der Waals equation, which is for real gas. In the previous lecture, we will learn about ideal gas equation. In this lecture, we will learn about real gas equation. Firstly, we will discuss compressibility. What is compressibility? Compressibility is a measure of how much a substance can be compressed or how much its volume decrease under pressure. We know that if we increase pressure on gas, its volume get decrease. It is an important property in thermodynamic. We know that thermodynamic is the study of heat change. Compressibility. This is a dimensionless number that describes how much real gas deviates from ideal gas behavior. It is defined as Z is equal to PV and RT, where P is the pressure, V is the volume, N is number of mole, and R is ideal gas constant and T is temperature. Here Z is compressibility. Compressibility is a key factor in determining how much a gas deviates from ideal behavior. For ideal gas, Z is equal to 1. That means the gas follow the ideal gas law perfectly. For real gas, Z can be greater than or less than when indicating the deviations from ideal behavior. And one important thing, at high pressure, Z typically deviate from 1 because the volume occupied by gas and intermolecular forces become significant. If we apply pressure, then gas volume decrease and there is an increase in intermolecular forces. And at low temperature, Z deviate from 1 due to increased intermolecular forces, because at low temperature volume get decreased because volume is directly proportional to temperature. We know that ideal gas is PV is equal to nRT is a simplified equation that assumes gas behave ideally. However, real gas often deviate from its ideal behavior because, according to kinetic molecular theory, original volume of gas is negligible and there is no force of attraction among gas molecules. These two postulates of kinetic molecular theory are faulty postulates. They don't fit on real gas because in real gas volume of gas is not negligible and there is force of attraction among gas molecule. At high temperature and low pressure, the volume of gas is increased and there is a little or force of attraction. This means that at high temperature and low pressure gas behaves ideally. So let's correct these limitations. Let's move towards whiteboard and correct these limitations. We know that PV is equal to nRT. This follow kinetic molecular theory postulate, but for real gas it deviate from the behavior. Kinetic molecular theory, original volume of gas is negligible and there is no force of attraction among gas molecule. Ideal gas follow these postulates. That's why we tell about that at high temperature and low pressure gas behaves ideally and at high pressure and low temperature gas behave non-ideally. Because of real gas deviate from these postulate, gas molecule occupy finite volume. Firstly we discuss about volume correction. The volume of real gas is finite. Let's discuss volume correction. In this we suppose a container filled with gas. Now the volume of gas is equal to the volume of container. When we increase the pressure or low temperature, the volume of gas is decreased. And here you see the blank space, which is free space in the container, and in the red shade you see molecular volume, which is not attainable, and in the blue this is the volume occupied by a gas. After this, the gas can convert or change its state. Let's derive its equation. We know that PV is equal to nRT. Here we can find the value of V. We know that the whole container volume is equal to V free, available space for the gas molecule, and the volume of gas molecule. Here we want V free because available space for gas molecule. So V molecule here is plus, and on the other side it will be minus. V free is equal to V container minus V volume. Sorry for the spellings here, mistakes. V is the molecular volume occupied by the gas, and we can see here about V is the volume occupied by gas, and we can write it as V molecule is equal to B, and the value of B is equal to 4Vm. And this is the volume correction. After this lecture we will correct pressure correction. We will discuss pressure correction, and then we put the value of V and B, V and P in the ideal gas equation, so we can derive van der Waals equation for real gas. This equation holds when number of mole is same, n is equal to 1. If n is different, then we put V minus NB. Hope you understand, and if you have any question about this topic, comment below. We will discuss it, and in the next video we will also solve some problems. Good to see you. Take care. Bye bye.